Okay, this is the P2 paper from October 2021. It's question number 8. If I move it down so you can see all of the question, you can see that it's a differentiation question to start off with. We're going to do some work on stationary points, turning points here. We're going to do some work on increasing and decreasing functions. But then as you can see, the last part is going to be working out an area, which is obviously going to be integration and area under a curve. So 2 different topics within the same question. Let's just have a look at it then. So it says for part A, for the whole of the question, we've got the curve 4 over 3x cubed minus 11x squared plus kx, right? Okay, fair enough. Point M is a maximum turning point given that the x coordinate of M is 2. So this value here, if I drop that down there, that x value there is going to be equal to 2. Can we show that k is equal to 28? Yeah, hopefully. What we'll do is differentiate and put it equal to 0, won't we? So let's have a go at getting started with that. So part A, it says y equals 4 over 3x cubed minus 11x squared plus kx. And if I want a turning point, I'm going to do dy by dx first of all, differentiating. So multiply by the power, take 1 off the power. That's going to give me 4x squared. Multiply by the power, take 1 off the power, 22x. And then obviously the kx just becomes k. So that's my dy by dx. And if I know a maximum or minimum point or turning point, any of those at maximum or minimum, I always write this down, it reminds me, if nothing else, dy by dx is equal to 0. So that means 4x squared minus 22x plus k is equal to 0. And then they've said in the question that this happens at x equals 2. So at x equals 2, I'm then going to get 4 lots of 2 squared minus 22 lots of 2 plus k equals 0. And if you rearrange that, we get 16 minus 44 plus k equals 0. So k works out to be equal to 28. And that was the original part, was to show that k is equal to 28. Okay, so I've done that part. Part B says, determine the range of values for which y is increasing. So let's make sure that you've revised every part of your syllabus and you know about increasing functions. So increasing functions are where the gradient is greater than 0. So let me tell the examiner I know that. If it's increasing, then dy by dx has to be greater than 0. And remember, dy by dx is now 4x squared minus 22x, but I know what k is now, plus 28 is greater than 0. Right, okay, so it's just a quadratic inequality. I always tell my students when we're doing this, please do a sketch alongside what you're doing. So the way that we do a quadratic inequality, I want to know where this quadratic graph is going to be greater than 0. Just to remind you, what we're basically going to do is we're going to say, this is a positive quadratic. So this quadratic is going to look like that. That's what positive quadratics look like. All I want to know is, does it look like that? Does it look like that? Does it look like that? Or does it even possibly, look up here or down here somewhere? So in order to be able to do that then, what I need to do is to find put that back for a second. If I want to work out whereabouts it is, I need to find what I call the 2 critical values. The critical values are where it hits the x-axis, where y is equal to 0. These are the critical values. So what I'm basically going to do is solve the equation 4x squared minus 22x plus 28 equals 0. And I actually say critical values. So I'm making it clear to the examiner. I'm finding those 2 points there. I don't have the diagram. Let's get rid of the diagram. I'll have the diagram later, but I don't have the diagram at the moment. So critical values are solving where that's true. This is one of their classic ideas. You could just stick it into the quadratic formula, but you're trying to impress the examiner if you know how to factorize. And at this stage here, as I say, they do one of these clever little things that they do all the time. Before I try and factorize it, everything divides by 2. So whereas I might have struggled to factorise 4x squared minus 22x plus 28, factorising 2x squared minus 11x plus 14 is a little bit easier to do. That factorises to 2x minus 7, x minus 2. As I've said in previous videos, if you're not sure how to do that, you can go back and check on the channel. There's some how-to videos that show you how to do that. This is going to give me x equals 7 over 2 or x equals 2. And now I can come back, and I will. I'll draw the very, very quick sketch of this. If I've got this situation, then what I know about this graph is it's hitting at 2 and at 7 over 2. Okay, so that value there is 2, and that value there is 7 over 2. So I found those two now. What was I trying to work out? I was trying to work out where the graph is greater than 0. Greater than 0 will be above the x-axis. It's those two areas there, those two regions there. So that's this side of 2 and this side of 7 over 2. We're not going to say that. Oh, we're going to say x is less than 2 and x is greater than 7 over 2. So all that together then is a solution of the quadratic inequality. Please don't do it. It only takes a couple of minutes. Draw the graph out. Draw the quick sketch of the graph, and then you're absolutely certain you're going to get the answers right for that part. Okay, on to part C. So it says the line L, let's go back to the question now. The line L passes through M and is parallel to the x-axis. Yeah, I can see that. The region R is shown. Can we find the integration? Can we find the, so looking back at my diagram there, can I find the area R there? Well, I can't from doing integration, because integration gives me the area under the curve. So integration would actually give me that area there. But that's okay, because I've got this rectangle here as well. So if I did the rectangle minus the purple area that I've just shaded in, that would give me my R. So in order to do that, all I've got to do is to work out what the value is up here, what that value is there, and that's just going to be f of x when x equals 2. So I'm going to work out what that value is there, and then I'll be able to go ahead and solve the rest of it. So let's make that clear to the examiner then. So I'm going to say part C. Find f2. I can't make it any clearer than that, I don't think. Find f2, putting 2 into the function. So that's 4/3, 2 cubed, minus 11 lots of 2 squared, plus 28 lots of 2. Work all that out. That works out to be 68 over 3. Now, I can show you on the diagram, but I'm always a bit wary about having information on my diagram in terms of the examiner marking it. But what I've just found is that value there is 68 over 3. Well, that value there is 68 over 3, but it means that it's hitting 68 over 3. So if I want to work out the area of the rectangle, I can do that now, and then I'm going to minus the area, which is the integral underneath the graph. So let's do the area of the rectangle first. So the area of a rectangle is just 68 over 3 multiplied by 2, base times height. So that gives me 136 over 3. So that's the area of the rectangle. If I now want the area under the curve is always the integral of y dx. Where am I doing it between? I'm doing it between 0 and 2 here, so that's nice and easy, no difficulties in working out the limits. So that's going to give me the area under the graph. So that's going to be between 0 and 2. The integral of y dx is the integral of 4/3 x cubed minus 11x squared plus 28x dx. And it's just a matter of going through and doing this now. Hopefully this shouldn't cause us too many problems. So integrating, add 1 onto the power, divide by the new power. Actually gives me x to the 4 there. They did that to make that quite neat. Next one isn't particularly neat. Add 1 onto the power, divide by the new power. Add 1 onto 28x squared divided by 2 is 14x squared. So it's that between 2 and 0. So sticking 2 and 0 into, well, sticking 0 is going to give me 0. Sticking 2 into that actually gives me 32 as the area under the curve. And so shaded area, as we said, is the area of the rectangle minus that area we've just worked out, and that works out to be equal to 40 over 3. Okay, nice question. Lots of different parts to that. Hopefully that all makes sense to you.